We are looking at Unit 6 test review today, and we're going to look at a couple things. Well, let's just start with the first section of multiple choice questions. We have two triangles here. We have an original pre-image, which is the one on the left, right here, and it has been moved this way. Remember, did it slide, flip, or rotate? Remember, if it slides, which is what it's doing right here, it's a translation. Had it flipped, it would have been a reflection. Had it rotated, it would have been a rotation. So this moved by translation, which was B. Number 2, this one is kind of tricky because our triangles are kind of overlapping each other in kind of a weird way. But what we have are two triangles. We have this triangle and we have this triangle. They're telling us that AC is congruent to BD. Well, AC is this side of that blue triangle. BD is this side of the red triangle. Now, then we have AD congruent to BC. So AD is congruent to BC. And now they share this third side. So what we have are two triangles with three sides that are congruent, which would be side, side, side. Right here what we have in our, we have triangle A is congruent to triangle, or angle A is congruent to angle D, A and D. C is congruent to F. And it says which additional statement does not allow you to conclude that the two triangles are congruent. Well, if we're looking at A, we're saying that AB is congruent to DE. Well, that would prove them congruent because of angle, angle, side. So that is not our answer. ACDF, here we have AC and DF. Well, that would prove them congruent because of angle, side, angle. And remember, we're looking for whatever it is not. So B is incorrect. And really, what I'm looking at, I look at B and E. Because if those two angles were congruent, then we would have angle, angle, angle. And angle, angle, angle is not a way of proving triangles congruent. So my answer there on 3 would be D. Number 4, what value makes these two triangles congruent? Well, remember, we have 78 degrees here, and we have 42 degrees here. We could have added the angles up, subtracted from 180 to figure that out. Well, if you'll notice, the side opposite 60 is 5.4 degrees. So that means the side opposite 60 here has to be 5.3. I said degrees, I didn't mean that. Just the length is 5.3. Opposite 78 degrees is 6.0. Opposite 78 would be 6.0, which means that x would be 6.0. The next one, it deals with corresponding parts of a triangle. If we've got corresponding parts, if we have two triangles that are congruent, then the corresponding parts are congruent. For instance, but we're looking for the conclusion that we cannot come to. A has M congruent to P. Well, they're the first letter of both triangles, so yes, those angles are going to be congruent. N and Q, those are the second letters, so they're going to be congruent. NO and QR, NO are the last two letters, QR are the last two letters, so those are going to be congruent. And then MN, which is the first two letters, and PR, which is the first and last letter, those are not corresponding. My answer in that case is going to be D. Okay, number 6. We have two triangles. We're saying that E and A are congruent. What else is congruent that's not labeled? Well, our vertical angles are congruent. So what's needed to prove these two triangles congruent? If I was to say that B is congruent to D, we would have angle, 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 which is not a way to prove them congruent. So that is not what we would use. That wouldn't prove them congruent. If we said that C is the midpoint of A and E, that would mean it splits it into two congruent segments. That would give us angle, side, angle. So that would be a way to prove them congruent. And the last one, BD is perpendicular to AE. Well, creating right angles, there is no hypotenuse leg. If that was the case, that would be true. So the answer in this case is B. Number 2 would be the only thing we would need to prove them congruent. Okay, name the theorem or postulate that lets you conclude immediately that these are congruent. Well, notice we have two triangles. Let me kind of redraw this for you. They're congruent angle right there. They're perpendicular, so these angles are congruent, and they share this side. So what we have is angle, side, angle, which is B. Number 8. This one, when we look at it, I looked at this one and thought, okay, let me compare these sides. UT would be corresponding to RQ, and RQ is a lot longer, so they're not congruent. It's just now a matter of, is it A or D? A says no, neither side has a right angle, but really that has nothing to do with proving triangles congruent. And D says each side of the triangle is not the same length, which is kind of why I said it, that they weren't congruent. So my answer to number 8 would be D. Number 9. We've got to name these triangles, or these triangles, to have corresponding angles. So we have M, N, O, and L, K, J. So we have to have corresponding angles. For instance, look at A and B. They start with K. Well, the angle corresponding to K would be N. And both of these start with O, so those are instantly knocked out there. Choice C gives us L, which would be corresponding to O, which it is. J, which would be corresponding to M, which it is in C. And then N and K would be corresponding, so my answer in that case is C. Okay, 10. Which of the following statements is not true? What we've got, if we need to, we can just draw two triangles and label them A, B, C, L, M, N. And again, we would have corresponding angles congruent here. A, B, C would be looking at choice A. A, B, C, and M L, N. A, B, C, we're talking about this angle. This angle right here. And L, M, N would be talking about this angle. Now remember, we're looking for what's not true. So that would be incorrect. BC and MN. BC would be congruent to MN. That would be true, so that's out. AB and LM. That is true. Now wait, hold on. I think I incorrectly marked one of these, or talked about A. ABC would be this angle right here. And I read that incorrectly. MLN would be this angle right here. We have ABC and MLN. Are those two congruent? They are not congruent, so our answer in this case would be A. Sorry about that. Okay, number 11. What we've got to do here is, we're talking about ratios, so we're going to write these ratios as 6x plus 2x plus 7x equals 180. And then solve for x. We end up with 15x equals 180 15x, divide by 15, and x equals 12. So now what do? I plug in 12 for each of these. 6 times 12 is 72. 2 times 12 is 24. 7 times 12 is 84. So what's my smallest angle? 24. What's my middle angle? 72. That's a 7. What's my largest angle? 84. All right, and 12. So we have these two triangles. Notice that we have segments QS and TV. Well, QS is the first and last segment. TV is the first and last segment. So these two segments are congruent. So I can set 4V plus 5 equal to 5V minus 7. Subtract 4V, I get V minus 7. Add 7, and I get 12. So V is equal to 12. Now, how do I find QS and TV? Well, I'm going to plug those in. So 4 times V, which we found to be 12, plus 5. 48 plus 5 is 53. And I do the same thing for the other one. 5 times V, which we said was 12, minus 7. That is 60 minus 7, which is also 53, which they were congruent, so we should get the same answer for those. Okay, here I thought we had a fairly easy one, because looking at this, looking at B right here, B is congruent to the other triangle, which is 12. Look at C. C is right here. It's congruent to 5. D, this angle is congruent to this angle, which would make it 60. E is congruent to this perpendicular or right angle, which is 90. F is congruent to this angle, which is 30. And then G is congruent to 13. Okay, name the angle included by the sides MP and PN. Well, we're talking about MP, this segment, and PN, this segment. So what angle is formed by those two segments? That would be angle P. Or if you named it with 3 letters, you could get angle NPM or angle MPN. All right, 15. Very similar to one we did before with dealing with segments, but this time we're dealing with angles. Look at angle B and angle Q. They are the second letter in the triangles, which makes them both congruent. So I can say that 4V plus 3 equals 6V minus 5. Solve for V. Add 5 to both sides. 2V equals 8. V equals 4. Now I plug those into each of those, so I'm going to say for angle B, that's 4 times V, which is 4, plus 3 is 16 plus 3, or 19. And then 6 times 4 minus 5. 24 minus 5 is 19 as well, which they're congruent, so we should get the same thing. Number 16, angle ACB is congruent to what? Well, angle ACB is ACB. It's the angle with the 2 marks on it. So look at the other triangle. Which angle has the 2 marks? Those right there. So we could call that either angle P. We could call it angle MPN or angle NPM. 17. We've got congruent triangles. We need to make sure we write them in the corresponding angles. So we start with X. So what angle is congruent to angle X? Well, that would be the vertical angle, so that would start with X. What about B? It's this angle right here with the 1 congruent mark, which would be congruent to C, and then that would leave us with D. Okay, what transformation leads to? Again, remember, is this sliding? Is it flipping? Is it rotating? It's sliding, therefore this is a translation. Okay, 19 we had a proof. Now, it gave us some information, so we have to put that in our statements. So ES is congruent to GL. Angle S is congruent to angle L. Next it says, well, let's mark that first. ES and GL, angle S and angle L. Next it says that vertical angles are congruent. Well, the vertical angles are these angles. So they give us EAS, which is this one. We have to come up with the other one, which is angle GAL. Now they're saying the two triangles are congruent. Corresponding parts of the triangle would leave us with triangle EAS is congruent to triangle GAL. And corresponding parts of congruent triangles are congruent. Remember, if we're trying to prove it and we're finished, that is going to be our last statement. Segment SA is congruent to segment AL. And 20, this is an often missed question. We know this missing angle by adding 60 and 50 and subtracting 1 from 180. So that means the side opposite the smallest angle is going to be the smallest side. So 10 is the smallest side in this triangle. The side opposite the largest angle is going to be the largest side. So nothing's bigger than 12, nothing's smaller than 10. That means 60, which is in between, its opposite side is going to have to be in between 10 and 12. Okay, this one also missed quite a bit. So what we have is an equilateral triangle, which means all the sides are congruent. This is 5x, and this is y minus 2, and this is 8x plus 1. If it's equilateral, it's also equiangular, meaning all the angles are 60 degrees. Well, this angle right here is cut in half, which half of 60 is 30. So y minus 2, which is that half angle, is actually equal to 30 degrees. Add 2 to both sides, and y equals 32. Now, these two segments are congruent because it says that RT bisects US. This is US. This is RT. That means this is also 5x. The whole length of that bottom segment should be 10x, which, if all the sides are congruent, 10x should be equal to 8x plus 1. Subtract 8x, we end up with 2x equals 1. Divide by 2, and x equals 1/2. So there's your x, and there's your y. Okay, this one right here, we have a triangle that if we were to add up all three angles, going to equal 180 degrees. So x plus 25 plus 2x minus 5 plus x equals 180. Combine like terms, and I end up with 4x plus 20 equals 180. Now solve for x. We get x equals 40. How do I solve for all the angles? I just plug them in. For A, 40, which is x, plus 25 is 65. For B, x is 40, so that's all it really is. And then for C, 2 times x, which is 40, minus 5. 80 minus 5 is 75. Write that again. There we go. All right. Okay, this one you have to be careful with. It's an isosceles triangle, but what two sides are congruent? Well, they tell us that it's PQ and QR. There's P, there's Q. So PQ and QR, which are these two segments right there. This one is 2x plus 1. This one is 3x minus 8. Those two segments are congruent, so we can set them equal to each other. 2x plus 1 equals 3x minus 8. Subtract 2x from both sides, add 8 to both sides, and x equals 9. How do we find the value for these? We just plug in 9 for x. So for PQ, 2 times 9 plus 1 is 19. For QR, 3 times 9 is 27. 27 minus 8 is 19. And RP, 9 plus 1 is 10. And that's all we got. Okay, 24. This one, probably one of the trickier ones, or the ones that give you the most trouble. Let's start with the midpoint. All we do is we take our x's and add them, divide by 2. So 11 plus 5 divided by 2, which is 16 divided by 2. So my x-coordinate of my midpoint is 8. Now I'm going to do my y's. Negative 3 plus negative 11 divided by 2 leaves us with negative 14 divided by 2, which is negative 7. Okay, I'm going to kind of zoom or pinch this and move it over here so we can have some space to work. Let's look at 2. Distance formula. I'm going to subtract my x's. So 11 minus 5 squared. Those are my x's. Now my y's, negative 3 minus negative 11, which makes it plus 11 squared. I end up with 6 squared plus 8 squared, which is 36, plus 64, which is 100. Well, the square root of 100 is 10. Let's hope those numbers are that easy on the test tomorrow, right? It's a little easier to simplify. And then the slope, we subtract the y's and we make a fraction, and then we subtract the x's as our denominator. So the y's are going to be negative 3 minus negative 11, which means plus 11, over 11 minus 5. That ends up giving us 8 over 6, which simplified is 4/3. Okay. All right, and then the last two on this page. What's the name of this segment? It's a perpendicular bisector. Remember, it's perpendicular and it splits it into two congruent, opposite side into two congruent segments. Remember, perpendicular bisectors don't have to start at the vertex. They can be anywhere, but they're going to be perpendicular and bisect that segment. Next up, we have a line that splits this angle into two congruent angles. That's an angle bisector. And this last page, a median and an altitude always start from the vertex. This one splits the opposite side into two congruent segments. That's the median. This one starts at the vertex and it's perpendicular. That's an altitude. Okay, right here, this is what's given to us. AC is congruent or bisects BD. That means it splits each segment into two congruent segments. And also AD is congruent to CB. That means we can use side, side, side to prove these triangles congruent. Now, if some of you happen to say, well, these are vertical, so we could have also used side angle side, that's true as well. So either of those would have been correct on this one. All right, good luck on the test.